how to build a .NET solution using hexagonal architecture. That is what we'll see today. No is not the same as a clean architecture template. And if you stay till the end, I will show you why. If you are not familiar with hexagonal architecture, take a moment to visit this video where I explain all the concepts around it. Before we start, it's important to say that there's no specific recipe on how to implement hexagonal architecture, and that is on purpose. Hexagonal architecture is not prescriptive at all. It's a set of rules that you follow to accomplish that kind of architecture. But it says nothing about how many projects should you have, if you should have even projects, or if you should structure your application using folders and files. It's completely up to you. The important part is the dependency rule that will allow you to be agnostic from delivery mechanisms and external tools. So now that you are aware of what hexagonal architecture is and that there's no specific implementation of it, let's take a look into my proposal, my go-to way of action when I'm implementing hexagonal architecture in .NET. And my approach is based on my experience, and I try to have a kind of a trade-off between not only being easy to manage that solution, but also giving you the degree of control on your projects, so you don't break that dependency rule that is so important without noticing it. That's why I will be using projects to enforce that dependency rule. Let's start by defining our scenario. Let's imagine that we need to provide an API, a REST API, that will fulfill the following case. So every time that a user of our service finishes reading a book, it will send us the ISBN of that book. We know the authenticated user, and based on that, we will perform some enrichment, let's say, and after that enrichment and validations, we would publish an event to Kafka, so other services in our software would know about that. And we also store that information into Postgres, so we can retrieve it. Knowing that, and knowing the concepts of hexagonal architecture, you know that you need the core application. Okay, this will be the center of your application. Here we will implement all the things that are related to rules, validations, enrichments, whatever, defining the flow. And it's there that we are going to start. Okay, we already know from my description that we have adapters like an API, that is the adapter with the protocol HTTP. But you also have Kafka, because I told you that you need to publish events. And we have Postgres, because I told you that we will be storing that information into Postgres. Let's start by our core application. Okay, let's start our journey by creating inside of this .NET solution all the projects that we need. And we'll start by the hexagon, or how I like to name it, the core application. So it's important to say that even I will be creating only one project, the core.cs proj. You can have multiple of them. For example, if you are following DDD, likely you will have, for example, an application and a domain project. There's nothing in hexagonal architecture that will require you to only have one single project. As I said in the beginning, you could even be doing this inside of the same project where all the adapters are. So take this with a grain of salt, and this is my recommended approach. Often, having a single project is more than enough. So let's jump into our terminal, and here I have nothing more than my solution file, a source folder empty, and a test folder empty, because in hexagonal architecture, tests are a requirement. If you look into the hexagonal architecture ideas and goals, you will see how important having the tests in place is. So let's start by creating some projects. So first thing that we'll be doing is using .NET CLI, create a class library for our core project that will go into our source folder. We will also add an XUnit project, core.tests. That project will add a reference to the core.cs proj, and we'll add both projects into our solution. So let's run this command. Done. Let's go to Rider and see how this thing looks like now. Okay, we have two projects. In this second one, we should have here a dependency on the core project. Perfect. Now you have defined your core, and this is basically the first step when you are building using hexagonal architecture. Now what you'll be defining is basically the ports through the outside world. Okay, so it's through those ports that you will be able to test this core even before you start implementing all the adapters that you need. So obviously here we will not do a full implementation, but we'll define at least the ports so you know how you can proceed. So we'll not be doing a complete implementation of the hexagon here, but we'll start by defining the ports. The ports is an important part because when you start implementing your hexagon, you will define the contracts with the outside, and now you will be able to implement your unit tests against that core application, even before having the adapters in place. So the first thing that I do, and I like to do, is first think about the operation that I'm fulfilling in this solution. So on that case, since I'm adding a function that will be able to add a book read, let's say, add book read, I will create a folder, and inside of that folder I will just create one file regarding my ports. I would not do this usually, but I'm doing it just for the sake of the demo, pasting some code that I already have, and I have three ports. One is this I add book read. This one will represent the inflow of information. So this is for my driving side of the application, and the other two are for the driven side. You can think about like this one will be used by my API. This one will be used by iBookRead Publisher, will be used by Kafka, and this one will be used by Postgres. But if you understand about hexagonal architecture, you know that since this API will only know this thing, now I could have multiple ones, for example, CLI, Blazor, whatever. Like here, I would be able not only to use Kafka, but also have different adapters. Like, let's say that I want to have here Rabbit, for example, or RabbitMQ. For Postgres, you could also use things like SQL Server, MySQL, whatever database that you want. So now that we have defined this thing, let's just move each one to its proper file. So I would be in a place where I could start implementing this core application. I can write my tests against those ports. I can mock the driven side ports. And once I'm happy with it, I can move to the next step. And the next step would be by implementing driving adapter. Okay, so let's get back to our diagram. And what we are talking about is that we'll be implementing, for example, this API that should be using this port. That is that port for adding book read that I explained you in the beginning. So let's do that. Let's get back into our solution and go to our terminal. Okay, so we will create some projects once again, and it will look like the other thing that we have done to create the core. So we have one adapter. This time will be a web API because it's our REST API that we are implementing. We will have as well a next unit project, and we'll add some reference. This time our test project has a reference to the adapter itself, but also our adapter will have a reference to the core. Okay? The core never knows its adapters. The adapters depend on the core. We add both projects to our solution and we run it. Perfect. Let's go to Rider and see what happens. So now I have not only the core, but also the adapter. Let's take a look on how this looks in our diagram. Okay, so in our project diagram, if we zoom in this thing, we'll see that our source will now look something like this. Your adapter API is depending on the core, and you have also the tests depending on this thing. Perfect. Now that we have our adapter, we can start implementing here the dependency on the port that we want. The port that you want, let's remember, is basically this add book read port. You can do this in many ways. You can use controllers. It can be, for example, a message handler that reacts to a message and calls your core application, whatever. Just for the sake of demonstration of the dependencies, what I'll be doing here is just show you that you could, for example, using minimal APIs, you can map here a post on a given path, and then you just reference your port and you call that port, providing the data that you want. I'm setting here user ID as 1 because I don't have authentication here, but ideally this would come from authentication. Now, obviously, what you need to do is to define through, for example, through dependency injection, what's the implementation of this thing, and then everything will work as fine. I have this adapter. Normally, what will happen now is that you iterate in this API, you implement the feature, and you test that API until the moment that you are happy with it and you are using mock data for those two other ports. And now it's the moment to create those two adapters, those ones on the driven side. So driven adapters are adapters that your core application will use, okay? They will call that adapter through the port. They don't know which implementation is there. And then that adapter should receive that data according to the contract and translate it into something that will connect to the technology, the delivery mechanism, protocol that is on the other side. For example, in this case, to Postgres, for example. So what you will be doing on this case, and let's start by Postgres SQL, is on our terminal, once again, let me just clear this thing. We will run, once again, the same kind of commands, creating a class library for Postgres, tests, adding references, adding to the solution. Now that it's there, let's take a look into our solution. And as you can see, I have here both projects. And obviously, you would come here into your adapter and you would basically implement, for example, this one. Let's say that this class would be the implementation of our desired interface. So the interface that we want to implement on that case is this one, iBook Read Store, okay? iBook Read Store. Let's just rename this thing to something that makes more sense. And then you will go to the configuration of your application and you will do something like builder.services. For example, add scope. And you define for that port, which is the implementation, and everything will work perfectly then. So next thing, basically doing exactly the same, but for Kafka. So let's go once again to our terminal, paste, and okay, adding once again the class library for Kafka, the tests, the dependencies between them, and then adding to the solution. Run, done. Going to the solution, we now can see that we have 3 adapters, we have our core application, we have tests for all of them, and obviously we would implement the implementation of that port into Kafka as well, and everything will be exactly the same as we have done for Postgres. The thing that I want to show you now is how our project diagram looks like. Let me just zoom in. Okay, and let's see what we have here. If we zoom in into source, what we have is that all our adapters, as you can see, depend on the core application. But there's here a small problem, as you can see. You can see that your API adapter is depending not only on the core, but also on Postgres, for example. And once I configure the dependency injection for Kafka, will depend as well on that one. And that is a problem because according to Hexagonal Architecture, an adapter should not know each other, because otherwise I have the risk that someone is writing code on, for example, a controller and will call directly Postgres for that. So what can you do instead to avoid this kind of problem? There's a concept that, for example, in the Clean Architecture book, you can find that is the compositional root. Some people name it the startup, the configuration, whatever. What I like to name it is basically my host. And usually a host is for a given purpose. For example, I can have in the same solution multiple hosts of this application. And my host, the way that I usually define it, is basically the starting point of my application. It configures the hexagon with a given set of adapters and starts a given application. For example, I could here have a host for an API and a host for a CLI. And to do that is quite simple. I will do another video on that, but I will give you now the instructions how you can think about it. Basically, what you'll need is a different, for example, console application that will depend, for example, on this API, the Kafka, the Postgres, so it knows every single project, and it will just send to this program.cs the configurations that you should inject through the builder services. Once you do that, now your adapter API can remove the dependency from the other adapters, and now you are sure that your API doesn't know the other ones. Obviously, this can be a lot of pain that often you don't need, okay? It's up to you to take that decision. If you are interested on how to do this startup thing, this host thing, just let me know on the comments and I will make sure that I have a new video on that. Before we go, I just want to leave you another note. As you can see here from our test projects, I have one test project per each project that I have here. So I have one for the core, one for Postgres, one for Kafka, and one for the API. The idea is that each one of those projects is basically testing that project itself. It doesn't wire up everything to see how it's going on. If you want more details on how to do that, what I usually do is having an application test project, is the way that I name it. And you can see on this video for my NDC Porto talk where I explain my testing strategy around this kind of architectures. It's useful not only for hexagonal, but as well for clean architecture. Okay, we come to an end. Hexagonal architecture is basically this. I created a core application. All my important logic will be there on the core. Remember, a core doesn't imply having a single project there. You can have multiple projects there. Then you create one adapter per each technology that you want to integrate with. If you are too strict to the definition, maybe you will think that you need, for example, an adapter. You need one adapter per each port. But I prefer to have a single project for all the ports related to a given technology because it becomes easier to manage. We don't want to have a huge number of projects in your solution. So you do that and then you make sure that each adapter doesn't know each other, so it can be simpler to test and you avoid problems in the future when you need to swap one of those technologies. As I promised you in the beginning, let's consider what is the difference between this strategy and clean architecture. So as you can see here, I have multiple projects, but I don't find the same concepts that we have in clean architecture. Let's open the known diagram that you have in clean architecture. So for example, these entities and these use cases, in fact, in my implementation, they are both inside of the core. But once again, if you prefer to have a use case project and an entities project, hexagonal architecture will not limit you to achieve that. Other important thing is that it's really common on implementations of clean architecture to have, for example, a project that is the presentation and a project that is the infrastructure. And usually all the things, all the adapters regarding to infrastructure, or you can also name them as driven adapters, they go into the same project. By doing that, you don't enforce the dependency rule as well as you do with this approach. Because having all of them in the same project, you have that risk that the coupling starts happening without you noticing. This is one important aspect on this approach. So what I will say is that while clean architecture is more prescriptive, there's also this part that you can find on the bottom right corner that comes from entity control boundary from Ivar Jakobsen that usually everyone ignores, but this is not part of hexagonal architecture as well. So while clean architecture has been built on top of hexagonal architecture and others like Onion and entity control boundary, for example, it's a more prescriptive approach because it combines a lot of ideas from all of those. Personally, I prefer hexagonal because it's simpler and doesn't impose a lot of rules and works in most of scenarios. A lot of time going with clean architecture is to use the wrong tool for the job. Thanks for watching. Let me know in the comments if you want to see another different thing regarding hexagonal architecture. It's a topic that I'm really passionate about, so it will be my pleasure. I hope that you liked. I will see you soon, and in the meanwhile, just keep things simple.